retrofit factories to fit robots, or build robots to fit existing factories. Should small-scale factories adopt robots? Zoryer's Industry Thoughts Episode 1. The underlying logic for evaluating robot adoption in the industry. The conventional industry logic goes like this. Establish standardized operating procedures, complete digital systems, and well-organized production line layouts first, then introduce robotic automation, and ultimately pursue benchmark lights-out, unmanned factories. Yet this model only suits one type of facility. Medium to large factories with mature management, highly standardized workflows, budgets for digital transformation, stable order volumes, and dedicated technical operation and maintenance teams. For these factories, 4 core criteria help decide whether to deploy robots. 1. High repetition, heavy labor, and harsh working conditions, positions such as material handling, welding, grinding, and palletizing, where human workers are prone to fatigue, errors, and work-related injuries. 2. Stable output with infrequent process changes, high volume, low variety production with long-term unchanged process stops. 3. Supporting foundational capabilities, capacity for production line retrofits, digital systems such as PLC MES, and on-site staff for commissioning and maintenance. 4. Calculable payback period, compare total costs of equipment procurement, retrofitting, and operation maintenance against labor costs. A payback cycle of 23 years is generally expected. This evaluation framework, however, is completely unsuitable for the vast majority of small and medium-sized factories. Small and medium-sized plants face real-world pain points, high-variety low-batch orders, frequent process revisions, no MES platforms, no full-time automation engineers, limited budgets, and survival mode operations. They cannot afford to finish full-scale digital construction before bringing in robots. The industry used to build benchmark lights-out factories, hundreds of robots, and end-to-end unmanned operations. A lights-out factory, nonetheless, is an outcome, not a starting point. Robots replace human labor as the final step only after factory management, digitalization, and processes are fully mature. Robots cannot rescue disorganized production lines. Many small and medium-sized enterprises blindly copy benchmark projects only to end up with idle robots, retrofitting expenses exceeding equipment costs, and total project failure. 2. A new contradiction, strong demand among small-scale factories without pre-existing digital infrastructure. A useful analogy, deploying robots in factories is similar to implementing AI within enterprises. Traditional AI requires high-quality data and standardized workflows to function. Conventional industrial robots work the same way. They rely on SOPs, MES, and well-fixtured tooling, and fail once site conditions shift. The market now shows a massive unmet need. Countless small and medium-sized factories lack digital infrastructure and standardized workflows, work in cluttered shop floors, and face frequent process adjustments. Still, they suffer labor shortages, difficult recruitment, and rising labor costs, and they too need automation tools. This has given rise to a new category of robots, solutions that do not depend on upper-level digital systems or extreme process standardization. Think of household robot vacuum cleaners. You do not write household core SOPs or renovate your entire home infrastructure. You unbox the device, complete simple setup, and it works out of the box, adapting to messy home environments. Future industrial robots built for small and medium-sized factories should follow this philosophy. No large-scale pre-retrofit of factory digital systems. No requirement for perfectly organized shop floor conditions. Deployable by ordinary workers, no senior automation engineers required. Rapid task switching to support high-variety low-batch orders. Mobile and on-demand, deploy wherever work is needed. This is the biggest opportunity brought by large AI models for industrial robotics. Instead of rigid pre-programmed instructions, vision and large model capabilities interpret real-world shop floor conditions. Robots adapt to irregular workpieces and variable working scenarios, lowering rigid requirements for on-site standardization. The industry long overlooked such pragmatic solutions, deeming them less sophisticated in favor of large benchmark projects. Real-world development has accelerated only in the past 1 to 2 years. Lights-out benchmark factories belong to mature large corporations that have survived market competition and entered profit harvesting phases. Numerous micro and small enterprises are still fighting for survival. From the perspective of technological equity, these heavily pressured small and medium-sized factories are precisely the ones most in need of automation tools. They do not seek flashy unmanned factories. They want robots that work, are affordable, and can operate without extensive factory reconstruction. The emerging future direction: build robots to fit existing factory conditions. The old mindset: retrofit factories to fit robots. Zoryer Industry Insights.